All right, so we are looking at the last little bit of section 3.6. So on Friday, we graphed systems of inequalities. So that's where we had the different colored pencils, and our solution region was that final kind of region where both of our graphs were shaded in. So there will be a question on that on your check at the end of the block today, and then a question that also deals with what we're going to look at quickly here. So this is in your student journals. On page 74, we're going to do 4 examples here. So this is solving a system, or excuse me, not a system, just solving an inequality algebraically. So looking at our first equation here, we have 16x squared is greater than 100. So we want to know what values of x is going to make this equation true. And like with any inequality, it's not just going to be one solution, it's going to be a set of solutions. So what we want to do first here is we want to think about this just as if it were an equal sign there. So if I have 16x squared equals 100. So we'll deal with that inequality part in the very end. At first, we're just going to look at it as if it were an equal sign. So I would divide each side by 16. And I'm actually going to leave it as 100 over 16. Because when I go to take the square root, I know that the square root of 100 is 10. The square root of 16 is 4. And 10 over 4 then is 2.5. So what I want to think about now is bringing that inequality back into this. So I'm going to create a number line, and really the only numbers I need to look at are the two that I came up with for my solution. So I have negative 2.5 and positive 2.5. All right, and since this is just a greater than, not a greater than or equal to, I'm going to think about those as open circles because 2.5 would not be a solution here. And I want to basically think about, am I going to be shading between those two dots or outside of them? So to do that, I want to test a number. So I'm going to test a number in the middle, and I want to pick something easy. 0 would be pretty easy to plug in. That's between these two values. So I'm plugging 0 into my original inequality. So I would have 0 is greater than 100, which is not true. So I know 0 is not a solution, so that must mean everything outside of the 2.5 and negative 2.5 are solutions. So we would say our solutions are x has to be less than negative 2.5, and that deals with this end here, or x is greater than 2.5, and that deals with this side of the solution. So any x value less than negative 2.5 or greater than positive 2.5 would make this original equation true. All right, let's look at another one here. So again, I want to think about this just as being an equal to, and we'll deal with that inequality in the end. So I'm going to get everything on one side here. So subtracting 15x, and adding the 34 to get this equal to 0. All right, from there I want to think about how could I solve this. So things like completing the square, factoring, quadratic formula. So factoring, I would have to think about factors of 34. Let's see, 34, 1 times 34. That's not going to give me negative 15. What about 2 times 17? So that's close. The problem with a positive 34 is they would either have to both be positive or both be negative. And there's no way I can get a negative 15 out of that. So I know factoring is not going to work. Completing the square would be kind of yucky with that 15 there, because half of 15 you start to get into decimals. So I'm actually going to do the quadratic formula for this one. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I would have, let's see here, simplifying under that radical then, 15 squared is 225. 4 times 34 is 136, all over 2. Under the radical, 225 minus 136 is 89. the square root of 89, then I'm going to go ahead and get a decimal for this. Just because I want to be able to set up that number line, so I need to know the exact values here. So then I'm going to do 15 plus 9.434 over 2, and 15 minus 9.434 over 2, so I can see what my solutions are here. So 15 plus 9.434 divided by 2 is 12.217. 15 minus 9.434 divided by 2 is 2.783. So those are our two solutions that we're looking at. So what we want to see then is where the solutions would lie on my number line. So I'm going to set up my number line. I'm going to put my two values. These are really the only two I need to look at. And since this is less than or equal to, I would have filled in circles here. So I need to see, is it going to be outside or inside? So let's test an easy point on the inside. Maybe 10. Seems like it would be pretty simple to plug in. So plugging in 10 to my original equation, I would have 10 squared is less than or equal to 15 times 10 minus 34. So 100 is less than or equal to 150 minus 34. So 100 is less than or equal to 116, which is true. So that means I would shade on the inside because 10 is a solution. So when it's this way, we can write this as one set of solutions. So we would say that 2.783 is less than or equal to x is less than or equal to 12.217. So this is another way to say that x can be anywhere between those two numbers. So this is the correct way to write this. That's the correct notation we're looking for. So this means between. All right, let's look at 15 then. So 15, we have kind of an ugly fraction in there that I know you all hate. So what we're going to do right away is get rid of it. So the way to get rid of a negative 1/5 is to multiply everything by a negative 5. So if I multiply every single piece by negative 5, I would get x squared minus 50x is greater than or equal to negative 25 times negative 5 is positive 125. All right, so this is looking a little better. Numbers are a little big, but that's okay. So we could end up factoring, completing the square, quadratic formula, whatever works here. Since we did quadratic formula in the last one, let's do completing the square here. So I'm going to get my blanks all filled in and ready to go. So I'm going to think about this as an equal sign until the very end. So half of 50 is 25. 25 squared is 625. So I need to add 625 to each side. So this would factor to x minus 25 squared equals 750. Taking the square root of each side, I would get x minus 25 equals, let's see, the square root of 750. We can get a decimal form, since we need to know where they fall on the number line, is plus or minus 27.386. So x is 25 plus or minus 27.386. And I would want the decimal approximation for both of those. So I'm going to do the adding. That gives me 52.386. And the subtracting. So what I need to think about then, on my number line, so this is an or equal to, so I do want to fill in circles there. I need to figure out, am I dealing with a between or an outside situation? So I'm going to pick something easy to check. 0 would be inside of here, so that's always an easy one. So if I plug in 0, I would get negative 1/5 times 0 squared. So this is just my original problem, plus 10 times 0 is greater than or equal to negative 25. So let's see, this whole left side would just be 0. It's greater than or equal to negative 25, which is true. 0 is bigger than a positive, or excuse me, a negative number. So I would shade everything inside, so 0 is true. So we would write this the same way as we wrote the last one. Negative 2.386 is less than or equal to x is less than or equal to 52.386. So that's another way of saying x can be anywhere between and including those two numbers. Last thing we want to do here, same idea, it's just a word problem. So the profit for a hot dog company is given by the equation, and they give it there to us, where x is the number of hot dogs produced and y is the profit. How many hot dogs must be produced so that the company will generate a profit of at least $150,000? So I know this is an inequality because they want the profit to be $150,000 or bigger. So they want, if this represents the profit, they want this to be at least, sort of greater than or equal to, 150,000. So this is my equation. So once I get that equation figured out, this is just like the problems on the last page. So looking here, these numbers are pretty gross. So most likely quadratic formula is going to be our best bet. So I need this to be equal to 0 first. I'll subtract 150,000 from each side. So negative 0.02x squared plus 140x minus 152. Oops. Okay, so setting up quadratic formula here, we would have opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to figure out what we would have under that square root. So I'm looking at 140 squared minus 4 times negative 0.02 times negative 152,500. And we can go ahead and get a decimal for the square root of 7,400. So this would be negative 140 plus or minus 86.023. So then I want to see what both of my solutions are. So I'm going to do the positive and the negative version here. So 1349.425. Or if I subtract, So then I want to set up my number line with these two values on it. So since we're talking number of hot dogs produced here, it's okay to go ahead and round this to a whole number of hot dogs. So we're going to say 1,350 and 5,600, and that would round to 51 then. So I want to test a value somewhere in the middle. How about 3,000 would be nice in the middle. So when I plug in 3,000, so back into my original equation here, we want to get a value for that, see if it's true.